In this course, we will almost exclusively write our VEX code inside of a node called a wrangle, which in reality is another low-level sub that's been neatly packaged away by side effects to make it easier to use for us. Now, one thing that is very special to Houdini and to VEX when using those wrangles is that you can choose for which parts of the geometry you'd like to execute this wrangle. That is, for which parts in your geometry you'd like to run your code. And what I did here in this scene, I dropped down a geonode and put down a grid, and then created an attrib wrangle, just like so. And an attrib wrangle, when I highlight this, can be set up to run over different parts of a geometry. When you type in wrangle into Houdini's search box, you can see there are different types of wrangles. For example, the point, primitive, and vertex wrangle are nothing more than the standard attribute wrangle, just set up to run over points, primitives, or vertices, respectively. So let's have a look at the generic attrib wrangle here. We will usually be writing code in this window here called Vexpression. And if you highlight this window and press Alt and E, you can open up another external code editor, which we won't be needing for now. In here, I will now create an expression to create a point, and we will go over finding and using these functions in a later part of this course. But for now, just accept that the code that I'll be writing will generate a point. So I'll drop down a function called addPoint, and it's got 2 arguments. Like so. Always finish your line with a semicolon and then click outside of the node to execute it. Now, interesting part here is in the run over drop down here. It is currently set to run over points, but it offers a bunch of different options as well. So let's start with the detail only once. And when I middle mouse on this node now, I can see we created a single point because this code here is run exactly once. And by running this code once, we just create a single point. Now let me feed in that grid here. My grid is a grid of 10 by 10 rows/columns. So I have 9 by 9 squares, which means 9 by 9 primitives, and 100 points in my geometry, which I can see when I middle mouse over this. 9 by 9 primitives, that's 81 primitives, and 100 points. And I also got 324 vertices. That is because each of my primitives here has 4 vertices. So 81 times 4 is this, 324. Back to my attrib wrangle, which is still set up to run over details only. Let's set it to run over primitives. And I've got these 81 primitives in here. And I can see now, instead of just creating a single point, I created a point at the center of each of those primitives. When I middle mouse over my attrib wrangle, I can now see I've got the 100 points coming in from my grid, plus the 81 new points that I just created by running this code over our primitives. So this code will get executed for each primitive, in our case 81 times. And this is a really important concept to grasp because it sets VEX apart from many other languages. This technique not only makes it very easy to write code that will be executed for each piece in a geometry, but it also makes it very easy to write multi-threaded code, because Houdini tries and run the code when set up to run over primitives or points in parallel. That means once you got a heavy setup with a bit more intricate geometry and a bit more intricate code, Houdini will automatically try and execute your code as fast as possible. Let's try setting this to points now. We can see seemingly not much changed, but when I middle mouse over it, I can see I have now 200 points instead of the incoming 100 points from the grid. So for each of the incoming points, I created another point. Again, my code here has been run 100 times, 1 time for each incoming point, and thus we effectively have now duplicated our point count. Next, I can run my code over the vertices. So when I middle mouse over my code now, I can see I've got 424 points now, which is the number of vertices. So we now created a new point for each vertex, plus the 100 points coming in from our original grid. And finally, the last thing I can do is I can run this over numbers. Let me just cut the grid here, and run over numbers executes our code a given number of times, which I can set up here. So now when I middle mouse over this, I can see we created 10 points. Because my number count is 10, so this code will be run 10 times. Let's set it to maybe 1,000, hover over the node again, and we see we now created 1,000 points, all residing at the center, by the way. It gets interesting when I let this run, for example, 100,000 times, and have a thread job size that is smaller than my number count. And Houdini now tries also to multi-thread the execution of my code here. So it tries to split those 100,000 times it executes the code into chunks of 1,024 executions each, and tries to distribute them on your processor's cores. So these are the 5 possibilities how Houdini can execute a given piece of code when written in a wrangle. And while it is difficult to say if there's any favorite of those methods, in my experience, in most setups we will be using a point or a primitive wrangle, because most of the time in this course we'll be manipulating geometry.